Hi students, welcome to the second video in conics. In the first one we talked about ellipse. Now in the second we're going to talk about hyperbola. What is a hyperbola? First of all, if we take the equation of a conic, this is as we said in with the video of the ellipse. If a coefficient of x squared and y squared are equal, I mean a and b same number, so it's a circle. If they are not equal but same sign, both positive or both negative, then this is called an ellipse. If a and b opposite sign, I mean here a is positive, b is negative, or vice versa, this is called a hyperbola. What is a hyperbola? A hyperbola is the set of all points whose sum difference is equidistant from two fixed points. Suppose I have two fixed points, f and f prime, called focus. And if I pick any point here on the periphery, if I measure the difference of these two distances in absolute value, no matter where you're going to get the same sum as difference, you're going to have that shape. In ellipse, we said the sum of these two distances is fixed equal to a, so it has an oval shape. In hyperbola, if you do the minus, it will be a hyperbolic shape like this one. Always I want to let you know that after proving, we're going to, here you have the proof of everything of the formula that we got. You start by the distance, d2 minus d1. We get at the end that these two formulas depend if it's horizontal or vertical. What I want to say, the equation of the hyperbola is x squared over a squared minus y squared over b squared equal to 1. If it was a plus, it is an ellipse. If a square equal b square plus, certainly here, but they are equal, it's a circle. If it's minus, it is hyperbola. In hyperbola, contrary to the ellipse, in ellipse we usually say if under x square is bigger than under y square, it's horizontal. If under y square is bigger than under x square, is vertical. In hyperbola, we don't look at the denominator. It does denominator will not tell us if it's vertical or horizontal. What will tell us if it's horizontal or vertical? If it start x square minus y square, it is horizontal. If it's y square minus x square, it will be vertical, regardless if denominator under x square bigger or under y square is bigger. So this is not an issue. So always if at x square minus y square, it is a horizontal, y square minus x square, it is a vertical. So we have asymptote more. You have the vertices as we did in ellipse. The covertex does not belong to the hyperbola, but we need it to graph the asymptote, and always we have in hyperbola two asymptote. The asymptote will be y equal plus or minus square root under y over under x. So here b over a, under y over under x, so a over b. And you can see in the second sheet the proof that c square is, because c here is bigger than a, is c square equal a square plus b square. In the ellipse it was c square equal a square minus b square. So let us go to GeoGebra. First of all, to check these, let me graph a horizontal one. So x squared over 4 minus, for example, y squared over 9 equal to 1. So this is an ellipse. Let me a hyperbola. Let me put the two focus. Focus C, you have the center. Center here, I'm taking the first example to be the origin. I have the vertices. The GeoGebra will give you only the two vertex because the other B does not belong to the curve, so it will not give the co-vertices. The asymptote, here I have two asymptotes as we said. So if I want to find the other vertices, later on we're going to know these are the two the co-vertex. Now, if you pick any point here on the periphery or of the hyperbola, and you do the distance here from H to the focus, which is H, and from H to the other focus, and you make the difference. So here M equal H minus I, here H minus I. So no matter if you do animation, as h is moving on the hyperbola, as you can see, this sum will not differ. Maybe here you have it -4 or +4. I must put it as absolute value. It will not change. So as you can see, this is the hyperbola. So in the hyperbola, as we said, if x squared minus y squared, it is horizontal, y squared minus x squared, it is vertical. Now, if I want to plot the hyperbola, let us forget these two asymptotes. So what do we do? Okay, and let me get rid of this point that we have it here. I think it was f, not f. So anyway, if I want to join, so what do? I draw a parallel to the x-axis, because I have, these are the two vertices and this is the co-vertex. I draw a parallel. So let me go to parallel line from point A to line, and from point G to line x-axis, and another parallel from A to this one, and from E, from the vertices, sorry, so from the vertex to the y axis. Here this is wrong, from parallel from D to this one. So as you can see, you have what? The four corners. If you join these four corners by two segments, by two line, for example, here till here, and from here till here, you're going to get the asymptote that we're talking about. Then when you have the asymptote, you graph the hyperbola because horizontal of that four. Okay, so this is how we graph the hyperbola. Now let us go to practice problem. You will understand more. This is the proof. As I said, you can read it by yourself. Let us go to the first application. I want to graph here. First of all, because you have x squared minus y squared, first of all, it's hyperbola because it starts with x squared minus y squared horizontal, regardless if under x squared is bigger than under y squared. This is, we use it in ellipse when you had a plus here. So center 0, 0. So a squared is always under the first one. No matter if you have x squared minus y squared or y squared minus x squared, always this is a. A squared is 16, so a plus or minus 4. Since it's horizontal, you have 4, 0 minus 4, 0. The focus will be the sum 25. It follows a. So c will be plus or minus 5, 5, 0 minus 5, 0. The co-vertex b squared is 9b equal plus or minus 3. It will be on the y-axis, so 0, 3, 0 minus 3. The eccentricity bigger than 1 in ellipse, it was less than 1, which is c over a. So 5 over 4 bigger than 1. And the asymptote always equal y equal plus or minus x, but the coefficient of x here, we put a plus or minus square root under y over under x. Under y, square root 9 over 16 is 3 over 4. How do we graph? You put first of all the center. The first thing we do, I have 2 points, 4, 0. This is 4, 0, the vertex. This is another vertex. This is the vertex, co-vertex 0, 3, 0, minus 3. I draw here a parallel from here, a parallel from here, and a parallel from this vertex. It makes what? A rectangle. When I do the rectangles, I take the four corners. Now I join it with this, it passes through the center. So this is the asymptote. Because it's horizontal, I start from A. I draw the first part of the parabola. It will become near the line, but it will not touch it. It's an asymptote to it. So here from that side also, and from that side also. Always, we don't have here major axis, minor axis. We have only one axis because b and b prime does not belong to the parabola, to the hyperbola. So the transverse axis is the axis joining a to a prime equal to a. Since it's horizontal, it is parallel to the x-axis. So let us do the other one here. We have a hyperbola because we have minus, because y squared then x squared. This is a vertical, center 0, 0. A squared is 9, so plus or minus 3, because vertical 0, 3, 0, minus 3, as you can see here. And the focus follows. Okay, so 9 plus 1 is 10. radical 10, so 0 minus radical 10, 0, 10, you can see here f and f prime. However, b square is 1, b plus or minus 1, it will be on the x-axis, so 1, 0 minus 1, 0. And eccentricity c over a bigger than 1. For asymptote, I write y equal plus or minus square root under y over under x. So under y over under x, root 9 over 1, which is 3 over 1. Now, if I want to graph it, I put the center, I take a 0, 3, this is a prime 0 minus 3, b 1 0 minus 1 0. So I draw this rectangle passing by a prime, b prime, parallel from b to b prime to the y-axis, and parallel from a to a prime to this one. I take the four corners, and then I join the points. And since it's vertical, so I draw here the first hyperbola. It will become near the line, but it will not touch it till infinity. And here the same thing. As you can see, it will become near, but it will not touch it. The transverse axis here, because it's vertical, it's parallel to the y-axis, equal to a. Since a is 3, it will be 6. Now I'm going to talk about examples where the center is not the origin. First of all, you have minus, it is a hyperbola. And this hyperbola is horizontal. Why here horizontal? Because it starts with x squared. So center is 2 minus 1, like we talked in the first video in ellipse. So first of all, a square is 4, a plus or minus 2, because horizontal 2, 0 minus 2, 0. The focus follows, you add 9 plus 4 is 13. So it will be radical 13, 0 minus radical 13, 0. It follows the vertices. The co-vertex does not belong, as we said, to the hyperbola. It's plus or minus 3, so 0, 3, 0, minus 3. Eccentricity c over a, radical 13 over 2 bigger than 1. And the asymptote y will be plus or minus square root under y over under x, so it's 3 over 2 of x. Now, because I want it with respect to x or y, I do a translation of 2 to the right and 1 unit down. So I add for every x 2. 2 plus 2 is 4, 2 plus 0, 2. 2 plus radical 13, 2 minus 2, 0, 2 plus 0, 2, 2 minus radical 13, as you can see. And for every y minus 1, so here minus 1, 3 minus 1 is 2, minus 1 plus 0 minus 1, minus 1 plus 0 minus 1, minus 3 and minus 1 minus 4, and 0 minus 1 minus 1. And for the asymptote, the y, I replace it by y plus 1 as it's written up. Plus or minus the x, I replace it by x minus 2. Don't put a square because this is a line. Now I put the center 2 minus 1. This is the center. I put a. I have a 4 minus 1. This is 4 minus 1. This is a. A prime, I have it 0 minus 1. And these are the vertices. The co-vertex that you have here 2, 2. This is b and b prime. So I do the rectangle, I take the corners, I join it, I have the asymptote. Because it's horizontal, I graph it asymptote. If you go to infinity here, it will become near the line, but it will not touch it. Because horizontal, the transverse axis is parallel to the x-axis equal to a, which is 4. Let us take fourth example. Here, it's an ellipse, it's hyperbola, here hyperbola. Why? Because it is minus, and since y square minus x square, it is vertical. So center here, don't do a mistake, put minus 1, 0, because you're used to start by polish this one. So 0 minus 1, why is minus 1? Because most often students do the mistake, they put minus 1, 0, and they work. Everything will be correct as a strategy, but this will be wrong, so everything will be false. So 0 minus 1, since it's vertical, so a square, as we said, this is always a 4, because vertical 0, 2, 0 minus 2, it follows the focus, which is radical 13, the sum. So it follows this one, 0 radical 13, 0 minus radical 13. B squared is 9, it's on parallel to the x-axis. So 3, 0 minus 3, 0, eccentricity c over a, bigger than 1, and the asymptote y equal plus or minus under y over under x square root, so 2 over 3. x. And with respect to x or y, like we did in the previous, I add for every x 0 here. And for every y, I add -1. You have these points, you can check it. And for y, instead of y, we write y plus 1. And instead of x, you keep it as it is, because here I don't have only x. So these are the two asymptotes. Now to graph, first of all, I put the center, which is 0, -1. I put a that you have here, 0, 1, as you can see it here. A prime is 0, -3. This is 0, -3. B is a 3, -1, the co-vertex. And -3, -1. I join it, the four corners. I do the asymptote. Because it's vertical, I graph it asymptote and to these two lines. And the transverse axis, because vertical, it's parallel to the y-axis, equal to a, which is equal to 4. The last example, if it's written in a reduced form, like this example, unreduced form. So first of all, we take the x's together and the y together, because x squared and minus y squared, the coefficients not equal but opposite sign, as you can see, opposite sign. So this is a hyperbola. So we know from beginning that it is a hyperbola. Now we take the x's together, then the y together. We have minus, we put minus outside. We put coefficient of x squared in factor. So I divide here by 4 and here by 4. Here, I don't have coefficient for y squared. I keep it as it is. Now, canonical, you put 4, big parenthesis. I want to write it in perfect square method. So x squared will be x. Here, we divide the coefficient of x by 4. You're going to get 2. You square it. Then you put always minus here. You can check in ellipse. We did this in ellipse in details video. You can go and check it. This was a grade 10 program. And you always square the number here, which is 4. Here, I put all square. Y squared will be y. I have a plus. I put plus. I divide coefficient of y by 2 like I did here. So 2 divided by 2 is 1. I put always minus. And I square this number here. I have 1. Now I expand distributive property. So 4 into x minus 2 square minus 4 times 4 is 16, minus y plus 1 square minus plus 1 equal minus 11. I take these to the other side. I get 4. To finish, I need to write it equal to 1, so I divide everything by 4. So 4 and 4 cancel out. Here you're going to get 4 and here equal to 1. So now it's in reduced form. Because you have x squared minus y squared, it's horizontal. You can check these by xiy, then x or y. You can do it by yourself, at least. You can practice and you can check using the GeoGebra. The asymptote here, y as it is, y plus 1 plus or minus x minus 2. Square root under y over under x. Square root 4 over 1 is 2. You have the 2. You put the points and you can find the equation. I hope that you got the hyperbola. Remains one video. I'm going to talk about the parabola.